Good evening, sir. Good evening.
Good evening, everyone.
Good evening, sir.
Good evening. Okay, so just in 1 minute, I'm starting with the class. Okay. So today you will have your test. Your test is live. After the class, you can attempt your test whenever you are free. It will be live up to 5 p.m. tomorrow. So you shall be doing it before that.
Okay, sir.
So in the in the chapter electricity, today we'll be doing some chemical effects of electricity. So we will do the movement of ions. Yesterday we discussed about the ions and we saw that ions are present. If ions are present in a solution, then if ions are present in a solution, then the solution will be conducting. If ions are not present, then the solution will not be conducting. So this is your chapter from your book. We have done all the basics. We have done the testing of it. So today we will do two types of testing. First of all, in the last class, we have done testing with LED. Today we will do testing with magnetic effect, and we will also do testing with testing of the electrolyte. What are electrolytes? Okay. So today we are going to do basically the depth of this chapter, which is for you. So you will have
That means this is the new chapter for us, right, sir?
yeah.
This is the new chapter for us, right, sir?
New chapter will be starting next week.
Okay. This is the continuation, right?
Yeah, in the same chapter, we have a subtopic called electrolytes. Okay. So we will discuss what are electrolytes and some chemical effects of electric current. Okay. Okay. So what are electrolytes? The substances, or the liquids which have ions in them. Liquids which have ions in them are called electrolytes. Now, if they have ions, they will conduct electricity. If they do not have ions, they will not conduct electricity. For example, yesterday we discussed about some of the ions. We discussed about the sodium ion, chloride ion, and some other types of ions we had discussed. So first we define electrolytes. Yes.
I think so.
Okay. So liquids that have ions present in them are called electrolytes. And we know that all electrolytes are good conductors of electricity. So this we had tested. Now testing, we will do a very important electrolyte, that is copper sulfate, that we will do. Using copper sulfate, we will do an important property that we call it electroplating. So here we will be discussing another important phenomena, electroplating. Okay. So you might have seen certain substances which appear to be gold. Some artificial gold. How many of you have seen artificial gold? Yes, Charan Tej has seen. I think you must observe artificial gold. Okay, so artificial gold is something, any ornament which may be made up of iron, may be made up of copper, but it has a very thin layer of gold on it. So that very thin layer of gold with which it is electroplated, that gives it a color of gold. So what is electroplating? Electroplating is the phenomena of putting a layer of one metal on the surface of other. So what is electroplating? The phenomena of putting a layer of one metal on the surface of other is called as electroplating. So in the case of electroplating, what happens here? We try to give some metals some precious color, some good color. For example, I have a spoon made up of steel, but I can make that spoon look like silver spoon. Okay, so that is by electroplating. I can put a thin layer of silver on the on a steel spoon so that it will look as if it is made up of silver. So I will show you some of the substances which are made up of, which have electroplating. So I will show you some electroplated substances. Let's see. We have electroplating. Electroplated substances. See here. In this article, if you look this article, look at these substances. So they look to you very shiny. Some of them appear to be made up of copper. Some of them appear to be made up of gold. Some of them appear to be made up of silver. Right? So they are not actually made up of gold. They are not actually made up of silver. They are just electroplated items. We have put there a thin layer of these materials. Okay. And the thin layer of these materials is called as electroplated substances. So here you can observe some other utensils, some other substances are also available which can be electroplated. So how many of you have understood what is electroplating?
Sir, I understood, sir.
Okay, understood what is electroplating? Okay,
Electroplating means placing one metal on the surface of the other metals.
okay. So which metal do we put on the top? Which metal do we put as the layer?
Gold, sir.
Not only gold, we can put other metals also, but it should give us a luxurious look, a better look.
Yes.
Okay. For example,
Yes.
we can put somewhere, we can put a layer of copper also. Somewhere we can put a layer of silver also. It depends that which look do we want. For example, we can see certain utensils. Just 1 minute.
Sir, whistle.
Yes.
Even whistle is a type of it, sir.
Which one?
Electroplated whistle.
Whistle.
For cookers, they will keep right, sir.
No, they are not electroplated. The whistles, they are made up of steel. They are not, but they can be electroplated. If you want to give it a good look, you can keep it electroplated. You can make it electroplated.
Like a steel, but it's there, sir. Actually, my home also it's there. Like steel visits.
Yeah, it's still. Now see how we perform electroplating. So the phenomena of electroplating, it involves the in the process of electroplating, we should have the formation of a salt. See? We will observe here a phenomena of electroplating being performed. Electroplating copper. Just 1 minute. Let's see how it happens. I want to show you actually how electroplating occurs. So see here. If you observe here, to make an electroplating, we have taken a beaker, and in the beaker we take a solution of the substance which is to be electroplated. For example, suppose here you have a jewelry, and I want to make this jewelry electroplated with copper. I want this jewelry to have a copper look. Okay, so I should take a salt which is made up of copper and make copper connected to the positive terminal of the battery. So these are the two things that we need to take care here while electroplating. While we perform electroplating, so we have to take a non-conducting beaker, and in the non-conducting beaker we will take a salt solution, and the solution should be made up of. So here we take the salt solution which will be made up of the substance for which we want electroplate. Suppose here we want to electroplate with copper. So we will take an electrode which is made up of copper. We will take here a copper electrode, and here we will take the substance to which we want to electroplate. For example, suppose we want to electroplate jewelry. So you take a jewelry or whatever that is to be electroplated. Let's make it like this. So here we take a jewelry and I want to electroplate it with copper color. I want to give it a copper color. Now to give it a copper color, I should make it cathode. So what are the two things that we should take care here? First of all, the solution that we are taking, this solution should be made up of copper only. If this is copper, so I should take a salt of copper. That means I should take here copper sulfate, CuSO4. If I take it silver, suppose I want to electroplate some article with silver color. I want to give it a silver color. So which solution will I take here? What type of solution will be taken then?
Iron sulfate.
Not iron. We will take the solution to made of silver. I want to electroplate it with silver color. Okay. I want the jewelry to be silver looking. So which color will I use then? Silver. Okay. So the solution that I will use, solution should be made up of silver color. Solution should be silver chloride, silver bromide, any sort of silver we will take. So here, these are the two things that are to be noted, that so the negative terminal is called the anode, the positive terminal is called the cathode, and we connect the two cells to obtain the battery. So this one is your positive terminal, this one is your negative terminal. The positive terminal is also called cathode. So positive terminal, it is also called as anode. The negative terminal is also called cathode. Okay. Now let us see how the actual process occurs. Okay, I will show you how actually this process occurs. Everyone should pay attention now. This is very important. This copper sulfate solution, the copper sulfate solution, it has copper ions present in it. So copper sulfate or CuSO4, it forms its ions. It develops into ions. That is, it forms copper ion and sulfate ion. Yes. So the copper ions here, they are present in the solution. In the solution, you are having some positive ions. In the solution, there are some positive ions. Okay. And in the same solution, you are also having some negative ions which are moving. And those negative ions are the sulfate ions which are moving in the solution. Okay. Now, if the battery is connected, if copper is connected to the positive terminal, so the positive charges, they will be repelled by the positive electrode. Like charges repel each other. Yes, Pranava, do like charges repel each other or attract each other?
Like charges repel each other, sir.
Like charges repel each other. So the positive electrode or the copper electrode will repel or attract.
Sir, this is plus and this is minus, so they will attract.
Okay. So positive copper electrode, it will attract the minus one.
Yes, sir.
And it will repel the positive charges.
No, sir.
Yes, it will. The positive electrode will repel the positive electrode. Like will repel the like. Copper, this is your copper. Okay. So copper is positively charged and it will repel the copper ions. These copper ions will travel from the solution to the electrode and get deposited over there. All the positive ions will travel and get deposited on this. They will get deposited on the ornament. So this is how electroplating is done. Whatever substance is to be electroplated, that substance is made the cathode. It is given the negative charge of the battery. The one which is to be plated on it, that is given a positive charge. And hence the ions, they move from the positive charge or positive cathode to the negative positive anode to the negative cathode. So here copper ions, they move from the solution to the negative electrode and get deposited over there. Is there anyone who has not understood how the electrolysis process occur or electroplating occurs? Anyone if not understood, I will explain it once more. This is a very important effect. Electroplating.
So can you explain one more time?
Okay, one more time. Okay. So let us see. We will first check up a diagram how the electrolysis process occurs. Or electroplating process is occurring here. 1 minute. I want to show you with some moving things. Okay, see what happens. This diagram actually explains you how the electroplating is occurring. You observe it from the beginning, what happens over here. See, the negative charges are moving from the negative terminal. They combine with the copper, which is present in the solution. And this copper sticks to the surface. See, this copper sticks to this surface. Are you getting? I'll show this once more. Show this once more. Okay. First, see here. Our solution, this solution, it contains two types of ions. It contains copper ions and sulfate ions, right? So the copper ions, they are pushed by the positive terminal toward the negative terminal. So they will be moving from positive towards the negative and get deposited here. Okay. So this is what is happening here. If you observe here, see, this
I
copper,
understood,
they are
sir.
understood.
Yes, sir.
Okay. Anyone else?
Good, sir.
Okay. So shall we move ahead now?
Yes, sir.
Okay.
Yes, sir.
Okay. Just 1 minute. If we can see this one also. No, it's not working. I want it moving. Okay. So one more, if I can show you. In the same way, we can electroplate silver articles. We can electroplate the substances made up of silver in the similar way. Okay. So let's see further. We'll also see some of the question answers from this chapter. Okay, the next one we have to do is magnetic testing. What is magnetic testing of a substance? In the previous class, we had used an LED as a tester. We had used a bulb as a tester. So we observed over there that sometimes the bulb may fail. Okay. So sometimes the bulb may fail over here. Okay. So we have that reason was that bulb on the principle of heating effect of electric current. So here we have used another thing that we call as the magnetic compass. Okay. So if you observe a magnetic compass always point in the north-south direction. So have you seen magnetic compass?
Yes, sir.
sir.
It is in my home, sir.
Okay. So you can even check it through your mobile. In the mobile also there is a compass. A magnetic compass looks something like this. It always point in the north-south direction. Wherever the north direction is, so in that direction magnetic compass points. Okay. Now,
It is in my home, sir.
yes. So if you bring a magnet nearby this magnet, if you bring a magnet near to this, so this magnetic needle will start showing deflection. It will not point in the north-south direction, rather it will show deflections. Okay. Now the same thing, we try to do this. Yesterday we studied that electric current produces magnetic effect. Right? When electric current passes through a wire, the wire behaves as a magnet. Okay. So here we have made a tester. We have a magnetic compass and we have wound that magnetic compass with wire. Okay. So here we have wound this magnetic compass with wire. Now, if the electric current flows through the circuit, the magnetic compass will show a deflection. So we can create our own our own tester by using a magnetic compass. Okay. So if there is a current, the magnetic compass will show a deflection. If there is no current, the magnetic compass will not show any deflection. Okay. So instead of using an LED bulb or instead of using a bulb, we can use a magnetic compass also as a tester to test whether there is an electric current or not. So yesterday we saw this LED bulbs. Then we got the new tester. Okay. Now see the chemical effects. What effects can be brought about by an electric current? So just we studied about the chemical effect, that is electroplating. So here there is a small experiment which can be done. So the small experiment here, we have taken a potato and the two wires, we have put the two wires in potato, a positive and negative, both are put in the potato. If you switch it on, if the switch is on, then the magnetic compass will show us deflection. Okay, so that means there is an electric current which is flowing through the potato. The circuit is complete. Then only the electric current is showing the then only the compass is showing the deflection, right? So we will observe if the current flows through it for a few minutes, we will observe a spot being developed near the positive end. We have put the two wires in potato. So at one of the end, we will see some color, some change of color. And that change of color would be, it is because some materials or some substances, they are moving out from the positive to the negative. So always remember, the substances, they are moving from positive to negative, since the direction of current is also from positive to negative. Everyone understood? The direction of current is from positive to negative. Therefore, in the solution also, the substance moves from positive to negative. Hence, in a solution, while performing electroplating, say here, we are performing electroplating now. So we have taken two copper plates, and we have put the copper plates in a copper sulfate solution. So if you switch it on, slowly we will slowly observe that this the copper plate which is connected to the positive terminal, it from here it passes to the negative terminal. Slowly it will become thinner and this negative one will become thicker. So Varshet, which plate will become thinner and which plate will become thicker?
Sir, the plate which is on the positive terminal will be thinner.
Yeah, which one will become thinner?
The plate which is present on the positive terminal.
Okay, the one which is connected to the positive terminal which will become thinner, and which will become thicker?
The plate which is connected to the negative terminal.
Yeah, the one which is connected to the negative terminal, it becomes thinner. It becomes thicker. Okay, so from where to where the substances are flowing?
Sir, positive to negative.
Positive to negative, right? So if I want to electroplate a spoon with silver color, okay, so I will use silver on which electrode? I will connect the silver material to which one, positive or negative? And where should I connect the spoon? Positive or negative?
Sir, negative.
Okay, spoon I will connect at negative. Very good. And where will I connect the silver?
Positive. Positive.
Positive. I will connect the silver at the positive end and I will connect the spoon at the negative end. Right? So in this way, the transfer of charges will be from positive to negative, and hence silver will be transferred from positive to negative. Can anyone tell me which solution should I take? Like here you have a solution of copper sulfate. See, we have taken a solution of copper sulfate. So if I am using silver, so which solution should I take then? Yes. Charantej, which solution should I? Which solution should be taken? Yes. Which solution should be taken? See here, the solution that should be taken, it can be taken any solution of silver. You take any solution of silver
Silver
to
sulfate?
electro. Yeah, we can take silver sulfate, we can take silver chloride, we can take silver bromide. Any
Solution only, sir.
Yeah, it should be a solution of silver. Any solution of silver will do.
Sir,
You
can
got
we
it?
take sir, can we take silver dioxide?
Silver dioxide. There is no silver dioxide. Okay. It will not be present in the solution.
Sir, silver chloride.
Yeah, we can take silver chloride. Okay.
Sir,
So, yes.
how do we know that this solution is there or not, sir?
That you will learn in higher classes, that which substances can form solutions and which substances cannot form solution.
Okay,
Okay.
sir.
Okay. Now here, you need to know some of the terminologies. See the terminologies which are to be known here. The anode and cathode, they are called as electrodes. Together we call them electrodes. So this is an electrode. This is also an electrode. Okay. The solution which is taken, the solution is called an electrolyte. So the solution is called an electrolyte. And here we take this, the vessel. The vessel that we take is called as electrolytic cell. Okay. So whatever vessel we are taking, that we call as electrolytic cell. The solution we take, that we call as electrolyte. The rods which are dipped in the solution, they are called as electrodes. And the positive electrode is called as anode, and the negative electrode is called as cathode. Okay. This process is called as electroplating. Sometimes we also call it electrolysis. There is another name called electrolysis. Or this complete setup is also called as electrolytic cell. We can call this.
Yeah, sir.
Yes.
In WhatsApp, I have already posted this in discussions, sir.
Okay. Which one?
Electrolysis, like
Okay.
like it will if we pass electric current through
Mhm.
a glass of water, impure glass of water, it will separate hydrogen and oxygen, sir.
Yes. So you can separate hydrogen and oxygen by the process of electrolysis. You need to use two electrodes and you need to add just a small amount of acid to water so that it will become conducting, and you can separate hydrogen and oxygen from water.
I had added a lot of topics in discussion, sir. I'm waiting for
Okay.
the replies. That's it. I added
Oh,
Ohm's law also, sir. Ohm's law.
okay, that's very good. Actually, we do not find some most of the time. So whenever I go through it, I'll reply it. Okay.
Yes, sir.
That okay. Certainly, we get very little time over there. So if I will check it out now, you have informed me. I'll check out if there is anything. I'll update on it. Right. Okay. Anyone having any doubt here? Okay.
Sir, what
So
is the
see,
electrolytic cell, sir?
yeah,
Electrolytic cell, you said. What's
yeah. The vessel that we use is called as electrolytic cell.
okay, sir.
So the vessel that we are using is called as electrolytic cell. We have also seen electroplating. So can anyone tell why do we perform electroplating?
To cover a substance with another metal to look posh, sir.
Yeah, to look posh. And there is another benefit. Sometimes it is beneficial in avoiding corrosion or rusting. So electroplating can also be done to avoid corrosion or rusting. Any other doubt?
Sir, is electroplating similar to galvanization? Galvanization.
Yeah, it's the same thing, but only difference being galvanization is a special type of electroplating where we use zinc as an electrode, zinc as the positive electrode.
Okay, sir.
Okay, so that's the same process. The only difference is that we use a specific zinc using the electroplating process. Anyone having any other doubt in this?
Sir,
Yes.
if iron is covered with another substance in the upper layer, even though it will get rusted, sir, inside.
It depends with which material it is covered.
Okay, sir.
Okay. Because different materials have different properties. So if it is covered with aluminium, it will not get corroded. If it is covered with zinc, it will not get corroded. So it depends which material is it covered with. Okay. So now let's see this. Most liquids that conduct electricity are solutions of.
Water,
So no, they are solutions of. Most liquids that conduct electricity, they are solutions of either acids or bases or salts. So either these are the three solutions which are generally conducting. The passage of an electric current through a solution causes which effects are caused? The passage of an electric current through a solution. Which type of effect? Is it heating effect? Is it a magnetic effect? Or is it a chemical effect?
chemical effects.
Chemical.
Yeah, it is a chemical effect, right? It is a chemical effect. Very good. Then, if you pass current through copper sulfate solution, copper gets deposited on the plate connected to which terminal of the battery?
Negative.
Negative terminal. Very good. The process of depositing a layer of any desired metal on another material.
Electroplating.
Electroplating.
Electroplating. Very good. When the okay, so just do this question number 3. We'll see this question number 3. Name the 3 liquids which, when tested in the manner shown in figure 14.9, may cause the magnetic needle to deflect. So, which 3 substances can make this magnetic needle deflect? That means they will be good
Impure
conductors.
water solution
Yeah, impure water and
vinegar.
vinegar. Very good. And
Salty.
salt
Salt water.
solution. Yeah, salt water or salt solution. We can have lemon juice. Okay. So here you have the bulb does not glow in the setup in figure 14.10. List the possible regions. So what can be the possible regions that the bulb does not glow?
Sir, if the switch is off.
No, there is no switch here. You can't see any switch.
Yes.
See, there are 2 possible regions. Maybe the liquid itself is non-conducting.
Not having the enough battery.
Yeah, not having the enough battery. Maybe the liquid is not conducting. Maybe there is a small current. Okay.
Or there may be another substance in the bulb rather than tungsten.
No, that is beyond our guesses. Okay, if you are taking a bulb, so you are sure that bulb is working. You can check that bulb, right?
The battery is like spoiled or used again.
Yeah, it can be the reason. Okay, so bye everyone. I think all of you have understood this chapter. This chapter is complete. If there is any
Yes,
doubt,
sir.
we will take up that doubt regarding this chapter in the next class. or we'll be starting a new chapter. Right?
Okay.
Okay, bye.
Sir, I have.
Sir, see my discussion, sir.
Okay, sure.
Sir, I have a doubt.
Yes, Charante?
Sir, you just now saw the figure, right? We can even say that no voltage in that wire.
Where? What happened?
Sir, you just now showed that image, right, sir?
Which image?
Just now you showed one image that why is
Yeah,
the
yeah, this
in
one.
that in that we can even say that there is no voltage, so the current is not flowing.
Yes. Yes, we can say that. We can say that there is no voltage.
Okay, sir.
Sir, the bulb
Okay,
should
bye.
not be connected to the negative terminal of the cell.
No, it can happen. Bulb can work even if it is connected opposite way. So the bulb can work.
Thank you,
With the
sir.
bulb, this is not the phenomenon. Okay, bye.
Sir,
Yes.
how can I write the test, sir?
You will write the test on a piece of paper, make it, scan it with a scanner, make a PDF and upload on the assessment app. Okay. If you need any help, you can type in the feedback section.
Okay, sir.
Okay, bye.